Paper 1 2019. Tricky one this. A different mass of sulfur dioxide was heated and allowed to reach the equilibrium. So we've got two SO3 in equilibrium and making two SO2 and oxygen. Amount at equilibrium. So they've got the moles of each. If I add all of those up, it comes to 2.12. I need to scale that down to be 1 so I can work out the mole fraction. So 0.32 divided by 2.12, 0.15, divided 1.2 by 2.12, 0.57, 0.6 divided by 2.12, 0.28. I've now got the mole fractions of each. What's different here is normally here you would be given the total pressure. And you'd multiply each of those mole fractions by the total pressure and plug it into the Kp. So it says calculate the mole fraction of each substance in equilibrium, which I've done. Give the expression for the equilibrium constant Kp, which is fine. Partial pressure of the SO2 to the power 2 multiplied by the partial pressure of the O2 divided by partial pressure of the SO3 to the power 2. Fine. Calculate the total pressure. So it's a back to front question, because as I say, normally you'd have the total pressure multiplied by the mole fractions, plug them into the Kp, and you'd be done. So what I'm going to do is, I'm going to imagine that the total pressure is the letter P. Now what I'd normally do is, I'd multiply the mole fractions of each of them by the total pressure, but I don't know it. I've given it the letter P. So the partial pressure of the SO3 is its mole fraction multiplied by the total pressure P, 0.15 P. And I do the same for the mole fraction of the SO2. 0.57 is its mole fraction multiplied by the total pressure P, 0.57 P. Mole fraction of O2, 0.28 multiplied by the total pressure P, 0.28 P. Normally, as I said, I'd be given P, and put the numbers in, plug them into Kp, and work out the Kp. This time, they've given me the Kp, 7.62 times 10 to the power of 5, and I've got to put the partial pressures in now in terms of P. Partial pressure of SO2 is 0.15 P, and it's squared, so that's 0.57 P squared, 0.57 squared, P squared. 0.28 P is the partial pressure of the O2, divided by 0.15 P squared for the SO3 squared. 0.57 squared, 0.325. Times 0.28p multiplied by 0.15 squared, which is 0.225, and I've cancelled p squared top and bottom. That works then out to be p, when I rearrange, is 1.88 times 10 to the power of 5. A tricky question that, because they've not given you the total pressure. You need to put that in as a letter and work it out. They gave you the Kp and wanted to work out the total pressure rather than the other way around.